This is Timothy Brusella again. I'm with my Math 1325 class, and we're working with the first derivative test. And since my students are the kind that really like the word problems, we're going to do some word problems now because that's what they prefer. They don't like those old drill problems. The microbe concentration B of X in appropriate units of a certain lake depends approximately on the oxygen concentration X, again in appropriate units, whatever they may be, according to the following function. Answer parts A and B. Okay, so B of X is the microbe concentration and X is the oxygen concentration. So I would think the more oxygen in the lake, the more microbes, but I'm not a biologist, I don't pretend to be, so I can't, but it seems to me like the more oxygen in the lake, the more microbes, up to a point. I guess if there's too much oxygen, maybe the microbes die off, but whatever. Find the oxygen concentration that will lead to the minimum microbe concentration. And what is that minimum microbe concentration? So in part A, we're finding the X value that leads to the, that'll cause it there to be a minimum microbe concentration. Part B, they want to know what is that microbe concentration. So in part A, you're finding X. In part B, you're going to have to plug that X value into the original function to find the microbe concentration. So here we go. Let's see, we have B of X. I'm going to recopy the original problem because that writing is mighty small. B of X equals X cubed minus 16X squared minus 140X plus 2670. And notice something. This function is only accurate for X values between 0 and 20. If we wind up with an X value of 30 as a critical number, we're going to have to discard it. Only acceptable X values that we get are the ones between 0 and 20. So we find our derivative. Differentiating, we get 3x squared minus 32x, okay, minus 140, I agree. And we want to know, when is that derivative equal to 0? It's never undefined. It's another polynomial function, so it's never undefined. But when will it equal 0? And is that factorable? Yes, it is. Amy, it's factorable. 3x and x, and let's see, 20 and 140. I thought 14 and 10, would that do it? No. 10 and 14. 14, I think 14 and a 10, does that do it? Yes. Multiplying that's what, a negative 42x plus 10x, a negative 32x. Yeah, that does it. So it looks like we're getting two numbers that we would think are critical numbers. What are they? Setting 3x plus 10 equal to 0, we're getting setting 3x plus 10 equal to 0, we're getting a negative 10/3. Is that okay? Is it between 0 and 20? We have to discard that. That's an unacceptable critical number. Set x minus 14 equal to 0. That gives us x equals 14. Is that okay? Yes, that is in the interval. That is an acceptable critical number. It is between 0 and 20. Now what do we do? We only have one critical number. That's pretty nice. Now what do we do? Okay, so we draw our number line to test it. Realize we're looking from 0 to 20. And I'll put 14 right in the middle, even though it's not in the middle. I want to have room to write on either side of 14, so I'm going to put 14 there in the middle. And I could test 0. 0 is included. I'm going to test 0. Test 0 and B prime. Plugging in 0 for B prime, what are we going to get? Remember, the exact value doesn't matter. Yes, it's negative, which means the function is decreasing. Okay, to the right of 14, probably the easiest thing would be 20. Yeah, we could check 20. Let's test 20 here. You could test 15. 15 squared is what, 225, but I think 20 is easier to square. 20 squared is 400. Plugging it into the derivative. So we have what, a 1200. And what are we doing to multiplying it by 32? So what is that, a minus 640? Minus 140? Positive or negative? Positive, so increasing. So it looks like the minimum microbe concentration occurs when the oxygen concentration is 14. Okay, so we do have a local minimum at 14. The oxygen concentration that will lead to the minimum microbe population is 14. Inappropriate units. I don't know what units they used to measure oxygen levels. So whatever it is, it's 14 oxygen units. I'll call them OUs, 14 OUs for oxygen units. And then part B, what is that minimum microbe concentration? That's where we have to take the 14 and we plug it into, well, you tell the original function. If we plugged 14 into the derivative, what would we get? We better get 0. That's where 14 came from. So plug the 14 into the original. So here we are. I'm running out of room on my paper. So I'm going to plug 14 into the original. B of 14. That's a 14 cubed minus 16 times 14 squared minus a 140 times 14. Plus a 2670. And punching that into my calculator, what are we getting? 318. I agree. So 318. So when there's an oxygen concentration level of 14, there are 318 microbes, and whatever the microbe concentration is 318, and whatever those units are, I'll call them microbe units. I'll call them, so for a 14 OU, a 14 oxygen unit, the microbe concentration is at 318 MU for microbe units. So here we have 318. Oops, so here we have 318. Any questions there?